Hello, everyone. Thank you for joining the Alert Team's press conference, where we are now connecting the dots between long-term illness and the BP disaster. I am Riki Ott, the founder and director of Alert, the Alert Project, and with me behind the scenes are Saskia Hotvaney and Sarah Mitz. When I went down to the Gulf Coast communities in May of 2010, I went as a concerned citizen. We had 20 years experience with the Exxon Valdez up in Alaska, and we had lost in court. I was worried that people in the Gulf might make the same mistakes that our communities in Alaska had made. Trust us, we will make you whole, trusting in what the government and the industry would do to protect the people and our workers. So I went down intending to share my knowledge and expertise. And 10 years later, I am still a concerned citizen. But now I also have the Alert Project. So I'm going to be sharing with you all what I hope will be a documentation of the harm and linking the exposures of water and air and blood levels to long-term harm in the Gulf Coast communities that we're seeing today. So it's no accident that Alert is kicking off 5 weeks of live streams and actions on the 31st memorial of the Exxon Valdez oil spill. The science and the events from this earlier disaster should have informed better policy for the BP disaster. Our goal now is to help the media understand how to connect the dots among key science papers, past and present, and this ongoing human health tragedy in the Gulf Coast communities that were impacted by the BP disaster. We need to get this story out and to help leverage policy changes to better protect our communities, our workers, our oceans, and our coasts everywhere during the next big one. As a matter of housekeeping, what we're going to be doing is you'll see the conference overview here, a little bit of witness, what I saw when I was in the Gulf during the first full year. And this includes the evolution of what I call a preventable human health tragedy. We'll also look at the science documenting the harm. And finally, we'll wrap up with unsafe practices, sort of a summary, and then solutions that we're doing and encouraging others to do with us. During the session, please post any questions via chat. And then at the end, we'll open up for a Q&A session after what I hope will be about a 40-minute presentation. If there are any follow-up questions or interviews that you would like to do, please email me at theALERTteam@gmail.com or Riki@alertproject.org. All right, and with that, I just want to say also that I had posted my introduction a little bit in more detail in advance, but I just want to say that in brief, I did arrive in Venice, Louisiana on March 4th, 2010, intending to use my firsthand experience with the Exxon Valdez and other oil disasters and my academic training as well. To coach basically people in the Gulf Coast communities about what to expect with their disaster and how to mitigate the potential for long-term harm to people, communities, and wildlife. I only intended to stay a month. Instead, I embedded voluntarily in the impacted Gulf Coast region, and I stayed through the first year memorial. I returned twice a year in spring and fall for a couple of months each time for 7 years. And during this time, I addressed people's evolving needs to understand toxic exposures and chemical illnesses. I stayed in people's homes, worked at their kitchen tables, talked in their churches, joined local rallies, celebrations, and even funerals. Next, please, Saskia. So during this time, I witnessed and documented on Huffington Post blogs the evolution of this preventable human health tragedy. And eventually all this work led me to founding Alert in 2014. And the goal of Alert, part of it is to bring accessible science and legal tools to those who need it the most. the communities on the front line of oil and gas activities. I also write expert testimony on human health harm from oil spill disasters. So when I was in the Gulf during this first year, I began to witness skin rashes on people who sat or walked on beaches that looked clean, but they weren't because the sand grains had a coating of oil contaminants. I witnessed chemical burns on people after they had handled or had been sprayed with dispersants. I witnessed respiratory problems, which were particularly tragic in children whose small bodies could not handle repeated rounds of steroids. I witnessed nosebleeds and hair loss, even in children. And this is across the entire Gulf Coast region, 4 states. The mothers of these sick children or the sick adults themselves were not at the table when the government, academics, and the oil industry representatives gathered to discuss lessons learned, what they had learned. The 2012 Dispersant Initiative report concluded that there was an acceptable level of human health risk as a trade-off for using dispersants. I wonder if the authors even knew of the harms or sat with any of the people injured by their decisions at their tables. It seemed that the hazardous waste could be put in, hang on. Yes, next slide, please. So at the onset, scientists and the industry and the government knew that dispersants were hazardous, that they are keys that open the door for oily poisons to go through the lipid cells of organisms and into the bloodstream and onto the organs. The photos show this. In the top left, this is a person who had gone collecting samples and his legs were burning, took a shower, washed with soap, they were still burning. So he sat down and someone, Rip Kirby actually took a photo with ultraviolet light. And what you see is the fluorescing of this with the oil dispersant combined. They are visible after passing through the skin barrier. They are not visible on the oil in normal light, but there they are as evidence that this happens very, very quickly. So the frame for this next section is that, and I'm going to use a couple frames here with quotes. This one is from Dr. Daniel Teitelbaum, an occupational toxicologist. And he says that for medical causation, you need to show a person was exposed to dangerous chemicals at dangerous levels. So the dangerous chemicals that I'll be focusing on are crude oil, specific components being the volatile organic compounds, beta-X, ethyl benzene, toluene, xylene, and the polycyclic aromatic hydrocarbons, the heavier molecular weight hydrocarbons. So that's one. Dispersants is 2. And then this third product, oil plus dispersant combined, also known as chemically enhanced oil. In 1989, Congress declared oil spill response was a hazardous waste operation and emergency response based on the AFL-CIO and OSHA pressuring Congress. This basically meant 40 hours of worker training, special procedures and equipment, medical surveillance, and long-term monitoring for all oil spills, including the Exxon Valdez. This designation happened 3 weeks before the Exxon Valdez. Next, please. Well, what happened during the BP disaster was that in the summer of 2010, the BP disaster, the federal government downgraded it. Just simply downgraded it for political convenience. Not recognizing a hazardous waste as hazardous means that workers were operating without adequate HAZWOPER training, the hazardous waste operator and emergency response training, and that residents, scientists, and visitors were seriously misinformed about health risks. It meant that hazardous waste could be put in municipal landfills. It meant that children could dig deeper pits than response workers who were told to stay above 9 inches. because the oil coating on the sand grains melted every day during the hot sun and midday, and it sunk down about 9 inches, cooled, and reformed, set up another layer of chemically enhanced oil. The workers were told not to dig that deep, not to get into that. The children weren't told that. Next, please. So regarding oil itself, after the Exxon Valdez oil spill, scientists found, they focused actually on polycyclic aromatic hydrocarbons. And they found that oil was 1,000 times more toxic than thought in the 1970s to wildlife. And this is up in Science magazine, 2003, down at the bottom. And it was also more toxic to people. And I summarized in my book a lot of the current literature at the time. That's Sound Truth and Corporate Myths, published in 2004. That book has 150 pages of references. And more recently, I summarized, again, the history of this in a much briefer expert testimony. So at this point, what scientists know and policymakers is that oil meets the official definition of toxic pollutant, even though it's not recognized as a toxic pollutant politically. And this definition of toxic pollutant is in both the Clean Water Act and in CERCLA, Superfund. And it basically says that these toxic pollutants, after discharge and upon exposure, ingestion, inhalation, or assimilation into any organism, will cause death, disease, behavioral abnormalities, cancer, genetic mutations, physiological malfunction, including malfunctions of reproductive system, and physical deformations in organisms exposed and their offspring. Next, please. So the older material safety data sheets, this is Corexit, one of the dispersants, 9527, and it was the published material safety data sheet in 2008. From this, you can see the hazardous substances there under section 2 are these toxic solvents and surfactants. So dispersants also meet the definition of a toxic pollutant. Dispersants are hazardous by nature. They contain oil-based industrial solvents and surfactants. Here it's 2-butoxyethanol and the propylene glycol and the acid salt. And you can see it could be up to 95% in Corexit 9527. So these solvents and surfactants facilitate the passage of the bulk of the toxins in the oil spill, in the oil itself, to pass through the lipid cells of organisms. In other words, dispersants act as an enhanced oil delivery system, taking the oil deeper into the bodies of organisms, including humans. Next, please. So these, again, this is the older 2008 data sheet. Corexit dispersants contain chemical ingredients known to be neurotoxins, mutagens, causing tumors, causing cancers, teratogens, able to disturb the growth and development of an embryo in the, or a fetus in the womb, and carcinogens. They're known to rupture red blood cells, causing hemolysis, bleeding, blood disorders, and liver and kidney damage, among other things. The older data sheets, the reason I'm showing you the older data sheets first is that they have a much more descriptive analysis here of the human health potential harm. Oil-based dispersants target the same systems and organs in the body as oil. So effectively, the body gets a double whammy when these two compounds are either combined or exposed at the same time. Now, the hazardous nature, as I just mentioned, is reflected in the older safety data sheet. Next, please, but not so much the newer ones. The newer ones have this very sort of circumspect section. This is 9527 again, but now 2020. And the current version reads more like a legal disclaimer. And you see in this section 11 now, for inhalation and chronic exposure, health injuries are not known or expected under normal use. Well, great, except non-normal use occurs during oil spill disaster response. During the BP disaster, spraying occurred within coastal waters, within 3 miles of the coast and in less than 10 feet of water. Spraying occurred at night and right over first responders, who were told that if they wore their protective gear, that could be an act of job termination. Spraying occurred long after the official reports that said that spraying had stopped. And some of this I put in the open letter to EPA published in the Huffington Post. Residents got sprayed while they were walking in public marinas, boating in nearshore waters, or walking the coast at night when the planes flew over. And how do I know this? Because I was there. I saw this. I saw the oil and the spray on my car windshields in the morning. I saw it in the beach umbrellas during the next day, outside the hotels. Basically, in other words, during an oil spill response, non-normal use is normal. One can practically expect harmful symptoms given the hazardous nature of these products. Next, please. All right, so to understand this chemically enhanced oil, we have to take a quick look at what happens when oil and dispersants combine and how oil spills weather naturally first. So what happens once oil is spilled on the water, crude oil, I'm talking conventional, is that most of what is evaporating into the air are these volatile organic compounds, benzene and others. Depending on wind and wave action, there can also be oil mist and aerosols generated and particulate PAHs thrown up into the air as well. Also, what happens is that the oil goes down into the water column, a lot of it. And in fact, it's pushed down by wind and wave action. And once it's in the water column, maybe make that box a little bit smaller. I can't see the sediment at the bottom. There we go. Whoops. Or not. So once the oil gets into the water column, it combines with naturally occurring organic matter. And it becomes the so-called marine snow, and also forms these cloudy plumes with bacteria and other detritus, and that these plumes and the marine snow eventually sink down to the ocean bottom. And so oil gets incorporated into the sediments. Now, during the first 30 days of the BP disaster, NOAA scientists estimated, based on aircraft measurements, that over 1,000 metric tons of soot particles were emitted from control burns, and over 10,000 metric tons of secondary aerosol particles were created by the evaporating hydrocarbons. Well, possibly by evaporating hydrocarbons, but not just from the oil. So next, please. What we see here first is the definition of dispersants. Now we're going to add dispersants to this oil spill. And dispersants, the definition proposed by EPA in its 2015 rulemaking, is that dispersants are typically mixtures of solvents, surfactants, and other additives that promote the formation of small droplets of oil in the water column by reducing the oil-water interfacial tension. Okay, so to reduce the oil-water interfacial tension, dispersants actually bind to and surround the oil droplets, resulting in this chemically enhanced oil, which is a different product than either crude oil or dispersant alone. So next, please. So these liberated chemically enhanced oil droplets not only enter the water column in greater numbers, they also enter the air in greater numbers, and ultimately the sediments in greater numbers. So the low end estimate for the BP disaster for with oil was about 14% of the BP disaster wound up the oil down at the bottom of the ocean. Aerial spraying of oil-based solvents, dispersants, over an oil spill that is naturally volatilizing oil and semi-volatile hydrocarbons means more overall hydrocarbons in the air, not less. The Gulf study mentions, for example, that when air concentrations of the volatile organic compounds exceeded 20 parts per million, as measured by the direct read instruments, water was sprayed, but above 70 parts per million, dispersant was sprayed to disperse the sheens. Well, meanwhile, down on the water, 15 of the 28,000 total hydrocarbon personnel samples, people who had vest monitors and stuff, were over 100 parts per million. 3 exceeded 200 parts per million. These levels are extraordinarily high. For example, when compared to the maximum air concentrations during the Exxon Valdez, which was this 5-month disaster response, and this are levels reported by Exxon, the level for benzene was 7.8 parts per million. For PAH aerosols, it was 8.6 parts per million. During the Brer, a tanker wreck in Spain, the total hydrocarbon concentration was 0.7 to 6 parts per million. And the Nahutka in Japan, less than 1 part per million. So next slide, please. So basically what I'm saying is that I think the dispersants contributed to the air quality problems. So for documenting exposure, now we're going to look at that quote again from Dr. Daniel Teidebaum. For medical causation, you need to show a person was exposed to dangerous chemicals. So we discussed the dangerous chemicals, adding in now at dangerous levels. So let's check out the science for the dangerous levels. And we're going to focus on three studies. So the first one is going to be the Southeast Louisiana Air Monitoring Study, the Gulf Study, and then a water monitoring study by BP. We're also going to look at a suite of studies, 3, that looked at the blood monitoring levels. And for more details on this, all of this, what I'm talking about, please refer to the Ott expert testimony 2018. And also a little bit later, we'll get into the 2015 one. Okay, so next, please. Now, this is a figure, the map from the Southeast Louisiana Air Quality Monitoring Study. And this was done by Dillard University and Texas Southern University. It's probably one of the most helpful studies I've ever read, but in particular in this disaster, because for 4 reasons. One, it actually selected its region around the largest potentially exposed population closest to the offshore oil. The time frame was critical. It was between May 1st to September 30th, and it coincided with the core period of oil spill emissions. The 3, it was well sampled and included the study itself included all the monitoring stations, not just the official ones. The other studies that later only looked at the official EPA sampling sites, and there was a lot more going on than that. And finally, 4, it actually analyzed actual data, okay, 4 compounds of concern, the benzene and the fine particulate matter, the PAHs. So that's the map. And all those red lines are actually the mobile monitoring units run by BP, and mostly by BP, and also some by EPA. All right, next, please. So first thing that these authors did was they looked at how the state and the federal governments game public health policy. They looked at how they game public health with numbers, meaning all these different screening levels. So if you look at the first two tick marks on line 4 and 6, you see that the US EPA set a standard for the BP disaster, a screening level which would cause them to either take action or not. And they set that at 20 parts per billion. This is for benzene, okay? But now go to line 5 and you see that that's above the Clean Air Act's unacceptable cancer risk level. Louisiana, the state, on line 6, set its own air quality standard for benzene at around 12 parts per billion, which is pretty indistinguishable from the unacceptable cancer risk level. So what the authors did was they decided, looking at line 11, that they were going to go and select a low cancer risk level to assess potential health harm. So using this standard, they found ambient levels of benzene were high enough to cause health impacts during the 5-month time period in each of throughout this whole study region, in every parish. The risk of exposures to and the ambient air levels of these hazardous pollutants were higher along the coast compared to the urban centers. The range was about 0.1 to 290 parts per billion. So, I mean, look at this chart here so you can kind of follow what these levels mean. Specifically, they found benzene levels went from the low end of the cancer risk range to basically the higher end, with about 100 times more risk of cancer, 100 in a million, from 1. So next slide. So for fine particulate matter, go to part B here. They found mean concentrations of 22, line 32, parts per billion, and these exceeded the national ambient air quality standards of what we saw was 12, okay? So during the oil spill, airborne levels of particulates, the polycyclic aromatic hydrocarbons, were approximately 2 to 3 times higher than concentrations prior to the disaster, indicating possible health impacts. And I'm sorry, the standard 12 is the national 12. So what they concluded was that the ambient air health, and they should have been a cause for concern and preventative action. Next. So in the next slide, we see that the federal government, oh no, never mind. You're right, stay on this one. All right, the federal government took I'm switching now to the Gulf study, the Gulf long-term follow-up study in 2018, but I just want to look at these standards here. The federal government took a very small number of airborne total hydrocarbon content. BP took thousands of these total hydrocarbon compounds. Both of these data sets, the federal government and BP, produced 80% non-detects, which means 0, or looking like 0, because the limit of detection that they both used was 0.4 parts per million, or 400 parts per billion. This is an order of magnitude over the Clean Air Act's unacceptable cancer risk level and 3 orders of magnitude over the low cancer risk level, meaning both of these entities, BP and the federal government, could claim that air quality was not a risk to public health based on their data. To its credit, the Gulf study, the Gulf long-term follow-up study, untangled these analytics with basically more analytics, but they were able to lower the limit of detection to 10 to 100 parts per billion, flipping the data set around, resulting in 80% detects. And the Gulf study also points out that dispersant vapor concentrations were not directly measured at all, nor were fine particulate matter, the PAHs, at either of the 2 primary sources, burning at the wellhead or the in situ burning offshore. So for the Gulf, from the Gulf study, this is useful because it points out how the federal government and the spiller use these very high levels of detection to effectively hide evidence of dangerous airborne exposures needed to prove causation. In summary, which is the next slide, the ambient airborne levels of benzene and PAHs, fine particulate matter, 2.5, in Southeast Louisiana during the 5-month peak emission period were at dangerous levels for public health and should have triggered preventative action. The ambient air levels of total hydrocarbons were also at dangerous levels for workers. And the federal air monitoring data and reporting requirements failed to accurately communicate the health threats in real time. The government and the spiller cannot be relied on to collect or analyze data useful for causation. So now we're going to take a look at the water monitoring studies in the next slide. And there we find this study. First of all, these water levels are important because the dermal contact is another important route of exposure for the responders, the fishermen, the field scientists, scuba divers, basically anybody who is swimming or wading or walking on the beaches. And an estimated 60% of the 210 million gallons of crude oil that blew out from the depth reached the surface. So, you know, it was distributed in the water column. And BP released its Gulf Science data set in 2016. There was an independent study that looked at it. This is that study, Samantha Joy and colleagues. And the map here shows the distribution of the samples that were a subset that were looked at for this study. And the questions the study asked were, where did the oil go? Where in the water column was it? What was the distribution? Were the concentrations of it at dangerous levels? And how did subsea dispersant injection influence the distribution and the concentration? And magenta here is within 100 kilometers of the wellhead, the blowout preventer. And on the yellow is within 10 kilometers. So the analysis, okay, I think that's the next slide, yeah. The analysis here captures quite a bit. They looked at alkanes, which is C5 to C12. That's the top band of data. And the bottom band of data is the alkanes heavier, slightly heavier. That would sort of mimic polycyclics in weight-wise. The range throughout this study, which was from May to the end of December, was actually, that's like less than 1 part per trillion up to 58 parts per million. This is a huge range, okay? But the salient points are that the red indicate levels of hydrocarbons that are in the upper 90th percentile. In other words, very high. The blue, which is hard to distinguish, are basically background levels to the median. And the green is from the median to these more dangerous red levels. And the analysis also captures the dynamic of the blowout containment attempts. And basically, it found that the subsea dispersant injection did pretty much not explain any of the distribution of hydrocarbons. Instead, it was a combination of temperature and pressure dependent processes, including like the sudden drop in pressure at the broken blowout preventer, a rapid expansion of the dissolved gases that pretty much shredded or atomized the oil into micro droplets, and cold water that formed those gas hydrates. Remember the pipes, the blowout preventer, and the ice? These actually at a more microscopic level trap the benzene. And all of these reasons literally blow away the need for subsea dispersant injection. The understanding that emerged from this study was that oil distribution was pretty much controlled by temperature and pressure dependent processes rather than dispersants, and also that water depth and time from the blowout controlled much of the distribution of the PAHs in the water column, not the volume of chemical dispersants. So I just want to point out that those red dots across the surface or the near shore in both of these bands indicate that there was dangerous levels of dangerous chemicals out beyond 100 days, 150 days plus within, for the samples collected within 100 kilometers. So, okay, so the next slide shows that the distribution, the summary slide, that the distribution of oil contaminants from the source, as I said, was controlled by temperature and pressure. The high concentrations of the polycyclic aromatic hydrocarbons persisted in the upper water column and at the sea surface through the end of 2010 and coincided with high ambient air levels of oil contaminants. And the dispersants did not accelerate oil degradation, breakdown, but it actually may have increased the residence time by killing off the bacteria that do degrade the oil, the residence time of these toxic chemicals. All right, so now we are going to look at the next slide, which is blood monitoring evidence. And again, this quote, for medical causation, you need to show a person was exposed. We're going to concentrate on the exposed part to dangerous chemicals at dangerous levels. So I think we can go to the next slide. The blood levels of crude oil compounds provide really strong evidence of exposure, and that they can be a critical link between exposures to airborne and waterborne oil spill contaminants and health effects. So there was a range of data that were collected. The first of these metamatrix volatile solvent whole blood profile testing was done pretty much 2 to actually 10 months. I meant to advise people to stop after 6 months post-disaster, but anyway, we got a longer data set. And then there was an official study that started up and assembled data, the metamatrix tests from 8 to 22 months. And then the Gulf study, 2 Gulf studies actually. And I'll talk about these in a sec. So that took it, started up well after the event in 2010. Now, before we can actually look at this, we have to understand oil chemical exposures and health. So let's look at the next slide. And what I witnessed when I was there, I witnessed what is now and was before known as acute symptoms that are common for oil spills. And it's this host of cold and flu-like symptoms. Those are the asthma and the flu, and then a host of neurological symptoms, the headaches and the brain fog, going down to blood indications of blood upsets with the ear and the nose bleeds, and finally the skin rashes and lesions, and being sick all the time. So this is from Dr. Ray, who told me that think of a person as a rain barrel, their body as a rain barrel, and over time they're accumulating these toxic materials in their body. We all know that, well, maybe we don't, but in the United States, children are born with upwards of 300 chemicals in their bodies that they get from the umbilical cord. And over time, through what we eat, what we breathe, what we drink, what touches our skin, this level just keeps creeping up. And in a toxic acute exposure where you get inundated, your body, your rain barrel can fill up, and then you'll get symptomatic. And the Institute of Medicine there at the bottom lists actually a chart with these very symptoms. Okay, so using the rain barrel concept in the next slide, we can now understand that when I listen to people, and this is people in communities, these are spouses of first responders who are out at sea. By early to mid-June, I realized that people onshore were experiencing the same symptoms as offshore workers. And you would expect maybe these symptoms and problems to occur first in workers because they're on the front line. But here I was seeing, and hearing about children and pregnant women, children, because they're smaller and their rain barrel fills faster when they get the same dose of air that adults breathe. They're respiring faster. Pregnant women, because their body's already taxed. Babies are picking this up through the umbilical cord, and elderly people because their rain barrel is almost already full. So all these people I'm hearing, and next slide, please, about, and this is when I started to get a little annoyed with the medical community because I thought they would step up. So here's the problem. Your body only has so many ways to say it's sick. So here's the common symptoms. You're clearly reacting to something. And the general practice doctors have basically three choices, but they don't really know about or have been trained about the choice C, the non-allergen choice. So they pretty much stop at, it's an allergy, it's a virus, it's a bacteria, it's something that you're reacting to. And let's go with the antibiotics and the steroid creams. And I saw people who were on their 6th to 8th round of antibiotics and nothing was clearing up. What I didn't understand at the time, but I found out later, was that medical doctors actually could not diagnose chemical illnesses because the diagnosis weren't reimbursable. ICD, International Classification of Diseases, that the medical companies all use and the insurance providers use, it didn't reimburse for chemical illnesses, which means that when the BP class action medical benefits settlement went through, chemical illnesses were invisible. So by mid-June, people began to ask me how they could prove that the oil exposures were making them sick. And that's when I advised them to ask their healthcare providers to get a Metamatrix whole volatile solvent whole blood profile done. During this time frame, I figured that the air was so hot. So this is like June now through July, that I realized what was in the Gulf Stream literally would probably be reflected in people's bloodstream. So let's go to the next slide. And sure enough, now these are all for the study. So on the far left is the first one, 2 to 6 months. We're going to look at these blood levels over time. And pretty much all the level tests that were shared with me, the blood levels of volatile organic compounds were in the upper 95th percentile and over. That 95th percentile, by the way, is set at 0.056 parts per billion. And the tests that I saw were 0.04. Well, actually, they were above that. And actually, they were even above 1.29. So what we were seeing were literally levels that were off the chart, okay? And Dr. Harbit, who is another occupational medicine doctor and more, warned that what we're seeing here is evidence that you inhaled it. It's in your blood. And he stressed that it was important for the medical community to look for end organ damage rather than the presence of a solvent, because solvents could have evaporated already, and the solvent could have already whacked the brain or the liver. That's the quote. Wilma Subra said that there have been long enough exposures to create chronic impacts, including liver damage, kidney damage, and damage to the central nervous system. So moving on to the first study. The first study, and I'm going to go a little bit quicker now. The first study, the 8 to 12 month study, showed that the volatiles were still in the upper 95th percentile, but the alkanes now, a different fraction of oil, the body was starting to break them down and get rid of them over more time as the air started to clear a little bit. The two Gulf studies that were done later, the 2.5-year and the 3-year one, the one nearest, the one in the middle, has this long tail going up to show that there was a distribution of volatiles up into the 95th percentiles still 2 years in, meaning that pretty much indicating I felt a lingering shadow of presumably much higher blood levels during 2010. And then pretty much things were back at baseline at the end of this. Okay. Now, the assumption in these Gulf studies is that these historic levels of hydrocarbons evidence in people's body do not influence the current physical health association. And the claim is that while it's possible that this population, their study population, experience with the oil spill may have influenced some of the associations they observed, they decided it was unlikely because the biological half-life of these chemicals, they should have been long gone, okay? However, Dr. Harbit observes that unusually high blood levels of these hydrocarbons, especially for prolonged periods, are predictors of long-term harm to blood and other organs. So let's take a quick look now at the material, at the minimal risk level, which is the next slide. And this shows down at the bottom the difference between exposure durations. Can we get the exposure duration up at the very bottom to show? The exposure duration for acute level exposure is 1 to 14 days. Intermediate, well, chronic is over a year, and intermediate's everything in between. And basically, what I'm suggesting is that pretty much everybody in the Gulf, residents and the workers, were exposed to chronic levels. And chronic levels actually do more harm, and you can think about it in terms of the rain barrel. You know, bodies are filling up faster than they're getting rid of this stuff. And at this point, babies are exposed during their whole developmental period, and these compounds are actually being parked, stored by the body because they can't get rid of them fast enough. And those stored chemicals become a toxic time bomb, basically, for disease and illnesses over the long term. Okay, so next, we're going to look at some of the study. Yeah, no, that's right, the summary slide. And I think I just summarized it, so we're going to go to the next slide right now. And now we're going to look at harm to people and wildlife. And here's Dr. Ray again, and the new frame is when you have sick people and you have sick animals and they are sick because of the same chemicals, that is some of the strongest evidence there is to prove that those chemicals caused that harm. So next slide, we're going to, the longitudinal studies, first of all, I want to say that there's earlier and ongoing studies before the BP disaster and they come from Spain and the Republic of South Korea. And the summary of these studies is that they identified long-term illnesses and diseases at this point from oil spill exposures from 2007 and 2000. The Prestige was earlier than that, 2004, I think. So these studies have been going on for a while, and they can now identify illnesses and diseases from the initial oil spill exposures. And what that looks like is they have been following the process of genotoxicity, which is chromosomal damage. And then that sets up instability and oncogenesis, which is to say cancers. And for example, in the blood work, what they found was they found specific harm in the stem cells in the bone marrow, so that's the genotoxic damage, leading to cancers and diseases of the blood, like T-cell lymphoma, acute lymphoblastic leukemia, and acute myeloid leukemia. And the latter, there are cancer clusters of these things in BP impacted Gulf Coast communities. Similarly, they followed this process of genotoxicity, finding the biomarkers, and then moving on to looking for the cancers in pulmonary function, respiratory function, and they found the same thing. They found by measuring damage to DNA and DNA repair pathways and RNA sequencing, it actually became predictive of asthma, cystic fibrosis, and chronic obstructive pulmonary disease. And they looked at exposure to Corexit separately, to epithelial cells, lung cells, and the damage from dispersants was worse than oil alone. They also were able to measure and find these biomarkers of 6 and 7 years post-event, indicating that the consequences of oil pollution may last for years. The biomarkers indicate that harm is still ongoing, and the harm may not, or it may, develop into future long-term illnesses and disease. So the biomarkers kind of warn of the presence of a still ticking time bomb in the body. All right, in the US, which is the next slide, the US, there's 4 longitudinal studies that 3 are still ongoing. 1 kind of wrapped up. It was the first one. It was a very small one, but it was also a very good study. And basically all of these studies, I'm talking about the Coast Guard cohort study, the Gulf long-term follow-up study, which you kind of have to read between the lines on to interpret what it actually found that's useful, and the women and their children study, which focuses on women and children. The others focus on workers. And the WATCH study focused on children in southeastern Louisiana. And basically, these studies are now finding kind of what Spain and South Korea already found. Okay, so we're on the same trajectory with worsening respiratory and pulmonary functions, giving way now to becoming diseases and long-term illnesses like chronic rhinosinusitis, reactive airway dysfunction syndrome, and more. And also worsening of blood, liver, and cardiac functions. Dispersant use also increased the prevalence and the frequency of the symptoms. So in other words, dispersant and oil combined made things worse. And lo and behold, the Coast Guard cohort study used personal protective equipment. A lot of them did, and it was found to reduce exposures, reduce the prevalence and the frequency of symptoms. And of course, we're still measuring the biomarkers. Okay, next. Oh, I wanted to mention dolphins, and I think I won't for the interest of time, but it's all in the testimony in 2018. Something to consider if you're interviewing people is to ask them if they had pets, dogs, cats, horses, birds. Did those animals, or did their pets get sick? I mean, this is not just wildlife that gets sick from these exposures. It's not just people. It's basically if you're breathing the air, you could be harmed. All right, so we're going to move to unsafe practices and solutions right now based on lessons the people have learned, okay? But first we have to take a quick look at our National Contingency Plan structure. Our National Contingency Plan is our nation's blueprint plan for preparing and responding to oil disasters. And before the Oil Pollution Act of 1990, it basically had two parts. There was a national plan and a team, and the United States and its territories were split up into 13 regions, and these regions all had plans and teams. Whoa, hold on. And, oh yes, go ahead. And after the testimony is available on the ALERT website under policy to answer a question. So go ahead to the next slide. After the Oil Pollution Act of 1990, nope, previous slide. We are missing a slide. Okay, just stay on that one then. After the Oil Pollution Act of 1990, what happened was that last box got filled in. And it got filled in because Congress decided complacency was rife and contributed to the Exxon Valdez oil spill. And the way to beat the complacency was to empower and engage local people. So local governments with local emergency planning committees, local citizens with regional citizen advisory councils, and also one of the things the Oil Pollution Act did, unfortunately, was pre-authorize dispersants. All right, so now let's go to the unsafe practices and solutions, which is the next slide. And what we have here is four basically ideas. So we have this, starting in the upper left, we have a very outdated national contingency plan. The last time it was updated was 1994. That's more than a quarter of a century ago. EPA started a rulemaking process and didn't finish it on rules governing dispersant use. That's when ALERT sued in January of this year to say, finalize that rulemaking. But we are not sitting around waiting for a lawsuit to end or resolve. We're also suggesting and we'll be circulating resolutions to people to go to their city municipalities, their city councils, to tribes, to go to their governing body, and to ask to start a pushback on this dispersant use. Basically, at this point, I feel with dispersants, it's sort of like the 1854 plague in London, the cholera plague, where they didn't know about cholera, but there was one John Snow that realized, oh my God, you know, everybody who's getting water from this well is getting this disease. So he broke the pump handle. And I think it's time to break the pump handle with dispersants. We can revoke, people can push back and get their states to revoke pre-authorization of dispersants. And we need to stop the subsea dispersant use. It's really contributing to a problem, doing more harm than good. Going over to the right top, we want to also build local capacity. It's in the same resolutions that we'll be circulating during this month of action. And the proposed resolutions are to engage the local government through the local emergency planning committees, to engage the local citizens through the regional citizen advisory councils like we have in Alaska, and to engage tribal governments through their tribal emergency response committees, all on oil spill disasters. And to not floods, fires, earthquakes, that's a separate program, okay? But use this same system and fund it through the Oil Spill Liability Trust Fund, which Congress would have to get involved in doing. So this is all possible to build up local capacity. Bottom left, it's about protecting workers and the public. We need actually to update the entire national contingency plan. It doesn't even include non-conventional oil or unconventional oil. So the tar sands oil, the dilbit, the frack gas and oil. The response plan doesn't work for any of that. And yet we drill and we transport these materials. It's not safe. we need independent programs for spill response, for managing public health and for managing workers. Massachusetts has an amazing plan, and I'll put those documents up in the Google Drive for the media to access, but basically they have a licensed site professional program, which is managed by an independent state board composed of citizens. And the licensed site professionals have to renew their contract every 5 years with the state. You don't have people who aren't trained responding to these hazardous disasters. You have people who are trained. And if the licensed site professional doesn't do a good job, the citizens can complain and their license gets pulled. Doesn't get renewed after 5 years. So there's some incentives to do things right. We don't have that right now through the National Contingency Plan. We need to separate the spiller and health of people, workers, and the public. We need to include air quality monitoring along with evidence-based action. If, as what happened in Mayflower during that disaster there, that Dilbit disaster, if children in an elementary school are throwing up because they're downwind of the oil that's running down the streets, they need to be evacuated, okay? That's evidence-based action. You get people out of harm's way, then you figure out what happened. What we're using now are standards-based criteria, and they're too high. So no action ever gets taken. Everybody's getting sick below where the standards are. And finally, we need to educate the public about this. This is serious. We're thinking of expanding the oceans, a drilling leasing program. You know, tar sands are more and more are coming across our railroads, our roads, into our ports and communities. And this stuff is hazardous by nature. People need to understand this. ALERT has a toxic trespass training program. We're kind of doing our part there, and we're relying on the media now to help us connect the stories of long-term illnesses with these oil chemical exposures. So I know we're running a little bit over, but maybe with this we could go into any questions if there are any.
Thank you, Riki. This is Sarah with the ALERT team. Right now in the chat box, we don't have any questions. If you do want Riki's testimony from 2015 and 2018 and a photo insert that documents the human harm, it's linked there on our website on the policy page. We might just, there's less than 10 people on this call right now. So if you'd like to ask questions, please unmute your mic and we can have a little bit of a discussion here.
Thank you, Sarah.
Hi, Riki. This is Dustin down in the Gulf.
Yes, Dustin.
I was wondering if this presentation is available anywhere.
Yes, we are going to be posting the slides and the recording itself as soon as we can up on the ALERT website.
Awesome. Also, the congressional tour is canceled in the Gulf for obvious reasons for the 10-year memorial, but they're looking for facts about dispersants in particular. Do you have any fact sheets or something that's a little bit more condensed? This is really good information, but I don't think that they're looking for something so so in depth.
The politicians are scared of the science, I think.
I know.
But yes, I was going to debrief with my staff afterward and let them know your request that you had mentioned earlier, that we need a bullet point talking sheet. I do have a dispersant myth and fact sheet, but I did like your suggestion of something more geared for the Congress people. So we'll be working on that. And thank you for that idea.
Yeah, they have really short attention spans. We got to get them while we got them.
Yep. All right, I think I'll just encourage people who have any follow-up questions to reach me on the alert, through the alert website. I'd be happy to talk to any media pretty much anytime about this. The reason we started this event so far in advance of the BP disaster was hopes that some of this information might find their way into this information might be helpful to media who are writing stories about long-term harm. So thank you all for joining us, and I think that will be the end of this press conference. Thank you all.